In this video, we're going to look at how we can use DNA to identify people. So as a review, remember restriction enzymes can cut DNA into pieces, and that your DNA is going to be a combination of your parents. So let's look at how we identify people using DNA. So the first way we can do this is by using a DNA sequence. So remember, each person's DNA sequence, the A's, T's, C's, and G's, is unique. And we can use this to positively identify them or compare their DNA. So you just match up, does this person have the same A's, T's, C's, and G's as this? And this is going to be the most sensitive process because since you're looking at the exact sequence and matching that up, it's going to be by far the most accurate. So here's an example. A soldier has their DNA on file. So they have sequenced particular sections of this soldier's DNA. And then if the worst happens and they need to positively identify some of the remains, what you do is you just match that up. And if it's an exact match, that's the same person. So those remains go with that soldier. If, on the other hand, it's not exactly the same, then that's not the same person and it probably goes with someone else. Now, another thing that we can do is create a DNA fingerprint. And this is a unique picture of your DNA. So it's similar to the fact that a normal fingerprint positively identifies you, but it's not the same thing. It's just using DNA in a similar way. And this is going to be a much easier process than a full sequencing. And so it's used a lot in things like paternity, identifying people, and forensics. So we are going to make a DNA fingerprint using a process called gel electrophoresis. Basically what that means is we are going to separate DNA fragments based on size using a gel and some electricity. So the first step is obviously we need to cut the DNA into fragments. So we're going to use restriction enzymes, and those enzymes cut at particular places. And since each person's DNA is unique, the sizes of the fragments are going to be unique to each individual person. Next, what we're going to do is make the DNA go through a gel. And this is what the gel electrophoresis part is. So we're going to use a gel and we're going to use electricity to pull the DNA through the gel. And the the gel is kind of like a briar patch. And so smaller fragments are going to be able to move faster through that briar patch than larger fragments. Just like a rabbit is able to move through a briar patch faster than a dog. So here I have a gel. I put my DNA here, I turn on the electricity, and it's going to run out and look like this. So this is an example of a DNA fingerprint. Each of these lines is called a band, and it represents a particular DNA fragment of a particular size. Now remember, the larger fragments don't move as fast, so they're towards the top. The smallest ones are towards the bottom. And so this gives me a picture of the DNA fragments based on size for this particular person. Now, let's say that I'm in a forensics lab and I want to identify a person based on some DNA found at a crime scene. In this case, I need for these things to match up exactly. So for example, I do a DNA fingerprint of the DNA found at the crime scene, and then I do DNA fingerprints of the 3 suspects that I have. Now, when I look at these, I can see suspect number 3 does not match up exactly. Suspect number 1 does not match up exactly. That means that that's not their DNA. Suspect number 2, on the other hand, every single band at the crime scene is also in the suspect, so that was their DNA. They left DNA at that crime scene. I can also use this for paternity, so figuring out who the father of a child is. And remember, in this case, the child, every one of their fragments has to come from either the mom or the dad. So I've done the DNA fingerprints for each of these individuals. What I find the easiest way to do this is look at the mom and the child first. So this child got these 4 bands from their mom, which means that they had to get the rest from their dad. So in this case, those 4 bands are accounted for by this dad. So this is actually the father of the child. If he was missing any of those, he would not be the father. Here's one more example that's similar to this, where we've got 2 couples and a baby, and we're not sure who the baby's parents are. So again, we can use DNA fingerprints. And in this case, let's look at couple A. Neither individual has this band that the baby does. Can't happen if that's their parents. All the bands have to be accounted for. So couple A, not this baby's parents. Couple B, on the other hand, every fragment that the baby has, one of the parents has it. So these are that baby's parents.